Okay, accelerated math. This is domain and range, relations and functions, and it's really just a matter of getting used to some vocabulary. So that's why we've got this one on here. You want to get comfortable with this as you move forward into function notation. Um, so domain and range, relations and functions, that vocabulary needs to become just commonplace for you. And let's start with domain and range. Now you guys, when you first learned about plotting coordinates, because you can see that's basically what these are, is that x went first and y was next. Okay. You also may have learned it as input and output. All right. And you also, and now we're talking about domain and range. And what I want you to see here, because some of these terms are not that, I don't know, common terms or whatever, but that you use every day, but x and y are in alphabetical order. Input and output are alphabetical. Domain and range, alphabetical. So at least one thing good about the way they call these things, all these different terms, is that they're all alphabetical, so you should be able to remember that. So the domain has to do with the x values and the range has to do with the y values. Alright, and let's see what they're doing here. They're giving us a set of values, and that's all this is just set notation. So here's a set of values that they're giving us. They've got 0 and -3. You could think of this as an XY table, and here's 0, -3, 4, -2, and -5, +1. So again, here's the input, here's the output, also known as the domain and the range. Now you can't read that very well. Domain and range. So they're asking for the domain of it. So all they're really asking for is the input. Alright, so 0, 4, and -5. 0, 4, and -5. That's the domain. On this next one, they're asking for the range. So now they're just asking for the y values. And it's just that simple. Alright, -6, -4, and +5. Alright. Of course, they try to trip you up by getting you to pick that one, but you're not going to fall for it. Alright, find the domain and range of this function. Alright, let's listen to some of the words on this. The way this reads is, for the set of numbers such that x and y are a part of this linear equation here, x and y such that, that's what this bar right here really means, such that. It's kind of strange terminology, but x and y such that y equals 3 plus x. And in other words, if x is 5, then y has to be 8. If x is 15, you add 3 to that, and y must be 18. That's all it's saying. All right. And what is the domain they're asking? And so they're asking, what are the inputs for this? When you might be thinking, well, I don't know, you didn't give me any inputs. But think about this equation. Y, the output, is equal to 3 plus whatever you put into it. All right. Is there going to be any restriction or issue with putting certain numbers in there for x? And here's what I'm asking: can you put a negative number in there? Yeah, you can add a 3 to a negative number. Can you put a square root? Can you put a decimal? I mean, I can't think of any number that you would put in there that the calculator would give you some kind of an error on. You can add 3 to any number you want. Okay. So bottom line is that the domain is all real numbers. Okay, and the range, what could you get out of it? Well, it's all real numbers. I can't imagine there being a restriction on what would come out of this. So domain, all real numbers, range, all real numbers. Here's an example of something that would cause like it not to output. Let's say that y was equal to x squared. Okay, so you can put positive numbers, negative numbers, you can square a negative number. But what happens when you square a negative number? You get, okay, so for example, -3, if you put that in the calculator and square it, and you do want to watch out for this, I've seen this a lot. So if I put -3 and I hit square, watch this. Someone's going to think, oh wow, I didn't know that. -3 times -3, I thought it was +9. Well, here's the problem with these calculators. Watch out for this. Is that it's doing a little order of operations here. It's doing this exponent before it does this, applies this negative. I need to put that -3 in parentheses and square that, so it's squaring the entire number with the negative. So really, -3 squared is 9. Okay, and the reason I was showing you this was that you can put a negative number into this one, but the range, the output, is always going to be positive. So that might be where it says the range is where y is excuse me, greater than or equal to 0, and that's another way of a mathematical way of saying it's all positives. That's the only thing you're going to get out of that, and that's true for this equation. All right. All right, find the domain and the range, and I like this because they're giving me a graph here, and the domain is the input or the x values, and the range, the output or the y values. So now going across this graph, we're saying basically where is this valid? They really should put some arrows on here. Where is this thing valid in terms of the domain? Well, I'm going to tell you, if you're walking across here and you're at 1 over here, you can go down and you hit the graph. You're at 2, you're right on there. If you're at 3, okay, you're on the graph. 4, oh, some people are going to say, no, no, no. But you know what? This thing continues up, up, up. And it continues to move outwards as well. You don't see it that much because it's going up very, very steep, but it continues to go out. And so the domain of this one is all real numbers, okay, any number. So x is a real number, and it just means that any real number. All right, and then the y, but now here's a restriction, okay? You can see that the y values, the output that you could possibly get, could be anything up to infinity. But looking down this way, well, you know what? It cuts off. It cuts off right here, and there's never any of the graph down below here. So it stops at -4, so it's y has to be greater than or equal to -4. So the answer to this one is B. And that's it. All right.